Hello, good morning. How are you doing today? It's been a while, but we're happy to be alive. So I'm happy to have you to the class for this morning. Today we are going to look at a few discussions on binary arithmetic. We want to look at the general thing to do when you have binary additions, subtractions, multiplications, and divisions. It is confirmed that you might already have a way you do your own thing, but this is like the general thing. This is like something general for everyone, and you could also take advantage of this opportunity to teach yourself about how to get through this, so that before even the questions come to you, you already know how to tackle them. Alright, so today we are going to look at binary arithmetic, and I could quickly look at that. So what we are doing today is binary arithmetic. So I keep confusing this spelling each time. So this is what we have. Alright, so you have basically, it's understood that binary arithmetic is a very essential part of digital systems. So when you refer to digital systems, you're talking about computers and the likes, gadgets that use some of those things, and many other digital systems in the world. So for today we are going to look at binary additions. So let's look at binary additions. Binary additions. So of course it has rules. So rules for addition. So let's look at some of these rules for addition. So we'll look at the rules for all of them. So I have, let's say I have a case. So this is what the table is going to look like. So I have a case, and so I have case. So you have A plus B, and you have sum when you need to carry. Alright, when you need to carry. So a case of, let's say you have 1, 2, 3, and 4. Okay, so the case is like serial number. So like the first one, the second, the third, the fourth. This is not really important. So but this is where you have the work to do. So if you are adding, remember binary has to do with zeros and ones. So let's look at some cases that we may have, and whether we need to carry or we need to find the sum. Remember that sum means the result of adding two or more numbers, right? So in the case that you add 0 plus 0, what is the sum? The sum is 0. You don't carry anything. Alright, but in the case you add 0 plus 1, what is the sum? The sum is 1, and you don't carry anything. In the case you have 1 plus 0, the sum is 1, you don't carry anything. In the case you have 1 plus 1, it will give you, well, 0, then you carry 1. When I used to learn this when I was little, they say 1 plus 1, of course in binary, they say 1 plus 1 will give you 10. Okay? But we will still come to that. We'll still come to that. But this is like a table. So in in all the cases, the only places where you have zeros are in your 0 plus 0 and 1 plus 1, where you only carry when you have 1 plus 1, but they will give you zeros for both. You understand? If you remember when we also did directed numbers, and we said that the only times that you have subtraction is when you have plus times minus will give you what? Minus. Minus times plus, minus. But once they are the same, minus times minus, plus times plus, you get what? You get your plus. So it's like just a little bit of that. Okay, so this is our table. This is what we have, and we would look at this fourth case. The fourth case where you have 1 plus 1, the result is 0, and you carry 1. So how is that done? How is it possible that you could have that? So let's get it done with this. So these are the rules. So in the fourth column, where you have 1 plus 1, what will it give you? It will give you 10 actually. But it's not 10 you write, so you write 0. So you write 0 and carry 1. Okay, carry 1 to the next column. To the next column. So that's what we have, right? That's what we have. So that's the rule for binary additions. All right. Now let's look at some examples that we are going to use to find that. So let's look at some examples, all right? So for example, so this is our first example. Let's look at this example. You have 0, 0, 1, 1, 0, 1, 0 plus 0, 0, 1, 1, 0, 0. So let's place the digits the way they are supposed to be. So you have 0, 0, 1, 1, 0, 1, 0. Then you have 0, 0, 1, 1, 0, 0. So let's add this. So according to the table, what would 0 plus 0 give us? 0. What would 1 plus 0 give us? 1. 0 plus 1, 1. What would 1 plus 1 give us? 10, right? Then you put 0 and carry 1. 1 plus 1, 10. 0, carry 1. 1 plus all that. So that's what we have. Alright? That is what we have. Okay? What if we convert these things? What if we try to convert them to base 10? Let's see what we are going to have. Let's convert this to base 10. So you are having let's convert to base 10. Let's see what we have. Remember, you have, let me use table again. Let me use table again so that you see what we have. So we have 0, 1, 0, 1, 1. So 0 and 0. Alright, so 2 raised to power 0 will give you 1. Alright, 2 raised to power 0 will give you 1. 2 raised to power 1 will give you 2. 2 raised to power 2 will give you 4. 2 raised to power 3 will give you 8. 2 raised to power 4, 16, 32, 64. So we'll have, this is done. So we'll have, so let's start it from there. So you have 16, the one that have the figures, right? So 16 times 1 plus 8 times 1 plus 2 times 1. So we'll have 16 plus 8 plus 2. And that will give us 26 base 10. Right? Because you know why I did this? You said you already used to. That's why I say I keep advising my students, do not focus on one aspect of what you know. No. You will try other things. Right? I'm going to solve this using what you usually know. This one is the table form. Right? Find powers of 2 for all these things and place your figures. And when you do that, we get 26 base 10. So let's try the other one. So let's create some space. So I'm going to clean this. The other one, you have 0, 0, 1, 1, 0, 0. So you have 1, 2, 3, 4, 5, 6. So 0 times 2 raised to power 5 plus 0 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 0 times 2 raised to power 0. So put them in brackets. So this cancelled, 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 and also cancelled. So what do we have? So we have only this. 1 times 2. So you have 8 plus 4, and that is 12. So 12 base 10. That is for this second one. So notice that if I use this pattern, I will have to declare all, even 0 has to be declared. But check here, I didn't start saying 0 times 64, 0 times 32, 0 times 4, 0 times 1. I didn't have to do all that. It's not important. I only pick out numbers. So it's either you choose this or that. Right? You are given 2 ways to get the same solution. And that's what I advocate for. I do not advocate for just one pattern. What if it doesn't work for you in all respects? Right? So that's that. So let's see what we got. Let's see what we got. If you add these two together, if you add 26 and 12 together, so let's add to see what we get. 26 plus 12. What are we going to get? 38, right? Now let's convert 38 to base 10. Let's convert 38 to base 10 to see if we'll get the same answer. Let's convert 38 to base 10. Sorry, to base 2. That's binary. So converting 38 base 10 to binary. So you have 38. You know how we do this? 2 into 18 is 19. you must keep using 2. 2 into 19 is 9. Please remember 0. Remember 1. 2 here is 4. Remember 1. 2 here, 2. Remember 0. 2 here, 1. Remember 0. 2 here, 0. Remember 1. So what do we have? We move this way. We have 1 0 0 1 1 0. Was it the answer we got? Yes. So this is base 2. So which means we are correct. What I just did is a way to test whether what you have gotten. Remember, before we said we added 2 binary numbers and we got an answer. For you to confirm whether you are correct, you could convert these binary numbers to base 10 and convert your solution, convert your sum to base 2 to see whether they will tally. Once they tally, it means you are in order. You understand? Good. So that's how binary additions are done. They are not difficult. So let's look at binary subtraction. Let's look at binary subtraction. Let's look at binary subtraction. So let's look at the rules. Let's look at some of the rules. So we'll have a case. You have your A minus B. You have subtract. You have borrow. So first case, second case, third case, and fourth case. So if you have your 0 minus 0, what will it give you? It will give you 0. You don't borrow anything. If you have your 1 minus 0, what will it give you? It will give you 1. You don't borrow anything. If you have 1 minus 1 to give you 0, no borrowing. But if you have 0 minus 1, it will give you 0, but you must borrow. Do you understand? So just like you have your usual subtraction, 0 minus 0 is 0. 1 minus 0, of course, is 1. 1 minus 0 is 1. Sorry, 1 minus 1 is 0. No borrowing. But 0 minus 1, of course, 0, nothing. You can't pull out 1 from it. So you need, it will still give you 0, but your 1, you borrow from the next column. Alright? So that's the table. That's like the simple table for it. So let's look at an example. Let's look at an example where you can. So please, if I clean fast, all you need to do is pause before you get to the next thing I would say. So let's look at an example here. So for example, you have 0 0 1 1 0 1 0 minus 0 0 1 1 0 0. So just the same thing. So let's check that out. So 0 0 1 1 0 1 0 minus 'let's see what we have. From the table, 0 minus 0 0. 1 minus 0 is what? 1. 0 minus 1 is what? It's still 0. Right? It's still what? 0. But I wrote 0 there so that from a table you know it's 0. It can't work. But we're not going to write it down as the answer. It is 0, but you must carry. Right? So I pull out this. This becomes what? 1. So 1. So take a look at this. In our addition, when we said 1 plus 1 is 10, right? What if you say, if this one crosses over to meet the other one, what will you have? You have 10 minus 1 is what? Are you saying that? So when you carry and you put it here, so it becomes 10. 10 minus 1 is 1, right? According to this. So if you do the opposite thing, put 1 over to the other side, you have that. So 10 minus 1 is 1. You still have 0 here. You pull this again to this spot, so 10 minus 1 is also 1. Of course, the rest are zeros. They're not important. You understand? So you have 1, 1, 1, 0. This forms your binary solution or your difference. Okay? But notice that when we did our base 10, this gave us 26 base 10, and this gave us what? 12 base 10. If we subtract the two, 12 and 26, what will you get? 14, right? So let's see if we'll get the same thing when we divide with 2. So 2 here is 7, 2 here is 3, please remember 0. 2 into 7 is 3, remainder 1. 2 into 3 is 1, 1 remainder 1, and 2 here is 0, remainder 1. So what's our answer if we go up? So 1, 1, 1, 0, excluding the zeros at the back. So we have confirmed it that we are correct by converting 14 base 10 to binary. Alright? Okay, so that's what we have. I'll give you questions on all of them. So, but let's just go into multiplication. Alright? If you have not finished, you could pause the video and see what you have. Alright? So let's look at binary multiplication. So rules. So binary multiplication, it's similar to the way you multiply in decimals. Okay, it's similar to what you do in multiplying with decimals. The only difference is that zeros and ones are involved, but the rules are the same. So it is similar to decimal multiplication. So let's look at the table. So you have a case A times B, and you have multiplication or product. Alright, so let's look at the cases that we have. So we still have 1, 2, 3, 4 cases. So the first case, 0 times 0 will still give you 0. 1 times 0 will give you 0. 0 times 1, 0, while 1 times 1 will give you 1. It's that simple, alright? It's the same thing. It's just the same thing. Okay, so now let's look at an example. I'm rushing this because it's not as difficult as anything, alright? So let's look at an example. So it's from the example that we'll know whether what we are doing is correct or not. But you could just go back and check what you have, alright? So let's see an example. Let's use the same example. So you have the same figures, 1 1 0 1 0 times 0 0 1 1 0 0. Let's see what we have, right? Okay, so the usual way you do your calculations in decimals. So times 0 0 1 1 0 0. Okay, so so let's see what we have. So 0 times 0, 0, 0 times 1, 0. So let's count them. 1 2 3 4 5 6 7. 3 4 5 6 7. The same thing. 1 2 3 4 5 6 and 7. But for this one, we're using 1, so we have 0 1 0 1 1 0 0. So just the same thing. 0 1 0 1 1 0 0. So for the other one, we have 7 2 1 2 3 4 5 6 and 7. The other one, 1 2 3 4 5 6 and 7. So you add. Okay, so let's add. So this comes down to 0. This is 0 0. 1 plus 0 is 1. This comes down to 1. This comes down to 1. 1 plus 1, 10. 0 carry 1. 10 0 carry 1. So you have 1 0 0 and 0. So that's it, right? Okay, so that is that. So if you check your, so if you still convert 26 base 10, this is 12 base 10. If you check, you get 312 base 10. So let's see, 26 times 12, 2 times 6 12, 2 carry 1, 2 times 2 4 plus 1 5, 1 times 6 6, 1 times 2 2. So you have 2 1 3, the same thing. So if you convert to base 2, you see that you get the same thing, right? What I just did is to use my base 10 to multiply all that. Okay, all right, hope it's moving, right? We're flowing. Okay, let's go to divisions. Let's go to binary division. Let's go to binary division. Let's go to binary divisions. So it is also called your log division principle, right? It's called your log division principle. So it's similar to decimal division, right? It's similar to your decimal division, but this really does not take any table. So if you know your decimal division, you could easily do this. Okay, so let's see what we have. Okay, so now what we are using is 110, like 110. Okay, but we are not going to 110 cannot go into 1, can't go into 0, 1. So it goes straight to that. So you have to here. So you have 110, then you subtract 0, 1, 0. 1 minus 0 is 0. 10 minus 1 is 1. Are you seeing that? So now we have 1001. So with 110, so this is 1. So this, since you are working with this, so you get 110. So you still bring out 1 minus, so you still subtract. 1 minus 0 is 1. Now 10 minus 1. So I'm picking, I removed 1 from here and I kept it here. So you have 10 minus 1 is still 1. So 110. So 110 and 10. So you're having 110 and 000. So you see, it's as simple as that. Okay, so if you check your base 2, 110 will give you 7 base 10. This is already 42. This will give you 42 base 10. And check that your 110 will give you 7 times 6 is 42. So it's just that, right? So in summary, that's just all. So we've tried our addition, our subtraction, our multiplication and division. So it's not difficult, as you have seen. So let's look at some examples we have. So number 1, let's look at 101 plus 11. Number 2, you have 111 plus 111. Number 3, you have 1010 plus 1010. Number 4, you have 11101 plus 1010. Number 5, you have 11111 plus 11111. Okay, so that's that. Then for subtraction, you should try this one out. Try this one. So the first one, you have 110 minus 10. Number 2, 101 minus 11. Number 3, 1001 minus 11. Number 4, 1101 minus 11. Number 5, 10001 minus 100. So please try that out. Multiplication, you have 10 times 10. Number 2, 100 times 11. And number 3, you have 101 times 10. Number 4, 1011 times 11. Number 5, 11011 times 101. Number 6. Okay, for division, you have 100 over 10. Number 2, 111 over 11. Number 3, 1101 or 1010 over 100. And number 4. Okay, this is number 3, 1101 over 11. Oh, sorry, 11. Then the last one, 10111 over 10. So I did it in a tabular form so that it will enter all of them. So each of them is 5 in number, and all you need to do is to get it done. There are other calculations in there are other calculations in binary like this. All you need to do is to wait and get this one done and give me the solutions, and we'll see what we have. So thank you very much, and I think that sums up what we have on binary arithmetic. So you get to do this and send it to me, and I will know that you are actually following with what we have. So have a lovely day and cheers.